Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. Uh, I'm going to teach you all 9 subjects of physical science in detail. My course is going to help the students who are preparing for CSIR NET, GATE, NT exam, SET exam, Jest, TIFR, IIT-Jam, uh, and GATE exam and other exams related to physics. My courses are absolutely free of charges. So this is the lecture number 2 of quantum physics, which we are which I will teach you now. Unfortunately, guys, I had to disconnect the call last time, and that lecture was not completed. So now I'm going to continue the same lecture, and I really apologize for the inconvenience. Uh, Okay, guys, and also I would like to thank you everyone who subscribed my channel and supported me, and also I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my lectures, which are free of charges, and those lectures are absolutely going to help you to crack the exams related to physics. So guys, I'm going to start now. Okay. Last time, the class, I had to disconnect the class. So we were studying photoelectric effect. So I will explain it again, and I would request you please watch that lecture, which in which I have explained this in detail. So also I'll not write it. I will explain it again. Okay, quickly, and then we'll proceed further. Okay. So we were studying photoelectric effect. So first of all, what is photoelectric effect? Okay, I have explained this photoelectric effect in previous lecture, guys, and that time I had to disconnect the class, so that's why I'm starting again. Okay, so photoelectric effect is the emission of electrons from metal surface. So I would request you please watch my previous class uh, for photoelectric effect. Okay, I have explained that in detail. Okay, so emission of electrons from metal surface when the radiation is incident on it called photoelectric effect. Okay, so this is the metal surface, and this is the work function, and this is the beam of the incident light which incident on the metal surface, and these are the electrons which are ejected. Okay, okay, so there are some points which I will explain now. Okay, the first point is if the frequency of the incident radiation is smaller than the metal's threshold frequency, okay, no electrons can be emitted regardless of the radiation's intensity. So it means if the intensity of radiation which we are falling on the metal surface is less than threshold frequency. Threshold frequency, what is threshold frequency? Threshold frequency is the frequency below which the electrons cannot be emitted from the metal surface. Okay, so that is the threshold frequency. Okay, if it is below, if incident light, the frequency of incident light is below threshold frequency, in that case electrons will not get ejected from the metal surface regardless of the intensity. It doesn't matter if we keep on increasing intensity, but the electrons will not be emitted from the metal surface, because the frequency of electron is less than threshold frequency. Okay, that is the first point. The second point is, no matter how low the intensity of incident radiation, the electron will be ejected instantly the moment frequency of radiation exceeds the threshold frequency. Okay, so this point is saying no matter how low the intensity of, so intensity doesn't matter if frequency of the radiation is greater than threshold frequency, the electrons will ejected instantly the moment the frequency of radiation exceeds the threshold frequency. Okay, so if the lights or radiation's frequency is greater than threshold frequency, the electrons will ejected, doesn't matter how low the intensity of radiation or light is. Okay, that's what the second point is saying. And the third point is, at any frequency above nu zero, okay, the number of electrons ejected increases with intensity but does not depend on light's frequency. Okay, so it means at any frequency above, if frequency of incident radiation is above threshold frequency, in that case, if we increase the intensity of light, okay, in that case, if we increase the intensity of light, the number of electrons ejected will also get increased. Okay, okay, that's what this point is about. Okay, so next point is the kinetic energy of the ejected electron. Okay, just let me check, is my connection working fine? Okay, the kinetic energy of ejected electron depends on frequency. So the ejected electron's kinetic energy depends on frequency, not on the intensity of light. Okay, so it means the kinetic energy of ejected electron increases linearly with the incident frequency. Okay, so this is the graph. Kinetic energy versus frequency of radiation. Kinetic energy of ejected electron versus frequency of radiation. So if we draw the graph, then this is going to be this straight line. This is a straight line, guys. Okay. So so it is saying the kinetic energy of the ejected electrons increases linearly with the incident frequency. Okay. This is the graph. So kinetic energy means the energy is increasing linearly with the frequency. Okay, so and this is the metal surface, this is the work function, and this is the nu zero is the threshold frequency, and this is the light incident on it, and these are the electrons which are ejected, right? So now I will explain that. Now I'm going to explain how Einstein explained the photo effect, and we all know that Einstein has got Nobel Prize for explaining photoelectric effect. Okay, so how Einstein explained, I'm going to teach you now, and also I have explained photoelectric effect till now in my previous class, so you can watch that class. Okay, so so now I'll write so that you can make notes as well. So Einstein explained the photoelectric effect using Planck's hypothesis. We know that Planck hypothesis, right? So before that, I will also write here what is work function, and what work function is the minimum energy which is required to eject electron from metal surface. Okay, minimum energy required to eject electron from metal surface okay, is called work function of the metal, is called work function of the metal. Okay, so work function is minimum energy required to eject electron from metal surface is called work function of the metal. Okay, and similarly nu zero is the threshold frequency. Threshold frequency is minimum frequency required to eject electrons from metal surface is called threshold frequency, and that is denoted by nu zero. Okay, okay, so now Einstein explained the photoelectric effect using uh, Planck's hypothesis. Okay, okay, so I have already explained Planck hypothesis in previous class, in yesterday class, where I explained the spectrum of black body, how Planck explained the spectrum of black body radiation. Okay, so in that case, Einstein that Planck considered energy in the form of packets or bundles called quanta, right? And their energy is in multiple integral of h nu, right? That is, so using that Planck hypothesis, Einstein explained photoelectric effect. So what he did is he assumed that he assumed that he assumed that the light is made of the light is the light is made of corpus corpus corpus, each carrying each each carrying an an energy h nu called called photon. Okay, so Einstein says so any energy is made of photons, and and each photon energy is h nu called photon. Okay, when a beam of light when a beam of light when a beam of light of frequency nu of frequency nu is incident on metal surface is incident on metal surface, each photon each photon transmit transmits all its energy all its energy all its energy h nu all its energy h nu to an electron to an electron to an electron near the surface near the surface in the process saying. So each photon has energy h nu, okay, and the metals, okay, and when a beam of light of frequency nu is incident on metal surface, each photon, okay, so light is made of photons, okay, that's what Einstein said, and each photon transmit all its energy h nu to an electron near the metal surface. So complete photon, the photon will give complete energy h nu to the electron, okay. In the process, the beam is entirely the photon is the process photon is entirely entirely observed by the electron, observed by the electron, observed, observed by the electron, by the, okay, in this process the photon is entirely absorbed by the electron. Entire photon will get absorbed by electron, okay. Electron, the electron will thus, the electron will thus absorb, absorb, absorbs energy, energy only in, only in quanta of energy h nu, quanta of, quanta of energy h nu, okay. So the electron will thus absorb energy only in quanta of energy, means so energy absorbed by electron will be multiple of integral multiple of h nu, okay. So it may be h nu, 2 h nu, 3 h nu, 4 h nu, 5 h nu, so on, but that will be multiple, integral multiple, okay. So n would be 1 2 3 so on, right, the integer, that would be integer. So they will the electron will absorb energy in the integral multiple of h nu. That's what this line is saying, okay. The electron will absorb energy only in quanta of energy h nu, okay. Okay, so irrespective of irrespective 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 of the intensity of the intensity, irrespective of the intensity of the incident radiation. Incident radiation. Okay. Doesn't matter how much the intensity of radiation is. That doesn't matter. But uh, yeah, only the electron is going to absorb energy in the multiple of h nu. Doesn't matter how much the intensity of radiation is. Okay. If h nu is larger than metal's work function, if h nu means energy. Okay. If h nu is larger than larger than if h nu is larger than the metal work function, the, the metal the metal's work function W, then the electron will be knocked out, means will be ejected. Okay. will be will be will be knocked out of the metal. Knocked out of the metal. Okay. Okay, so that's what Einstein said, and then he has given his equation, that is for electron h nu equal to W plus A, right? This is the Einstein's equation which Einstein has given. Okay, h nu, where h is the Planck constant. Okay, Planck constant, nu frequency, and K is the kinetic energy. Electron. Okay. Okay, so this is very important equation, and so we can also write is like here, so we can write K is going to be h nu minus W, and the value of K, that is kinetic energy of electron, or kinetic energy of ejected electron, is going to be h nu minus W. We can write h nu 0. Nu 0 is the W is the work function, and nu 0 is threshold frequency. And W is work function. Okay, work function. Okay, So guys, this is a very important relation. You need to note down and memorize it, and we'll solve some questions. Okay, so then it will get more clearer. Okay, and also we can write kinetic energy like this as well: h cut omega angular frequency minus w as well. We can write this as well. Okay, w is the work function. Okay, and right. So this is the equation given by Einstein. Okay. This is how Einstein explained. So we are not going in detailed derivation, right? Because we need all questions regarding examinations. Okay. Well, so this is the photoelectric effect, and this is the Einstein equation. We can say these all are the Einstein equations. Okay. We can write this as well like this: K equal to H. You can write this as well. Okay. So here also there is a stopping potential, right? So I'll explain that as well. The stopping potential is a formula that is EVS is equal to same, that is the stopping potential. Stopping potential. This is also the formula, very important. Okay, stopping potential. All of the electrons, even the most energetic ones, even the most energetic most energetic ones will be turned back, will be turned back, will be turned back before reaching the collector, before before reaching the collector. Okay, so that is the potential at which all of the electrons, even the most energetic one, will be turned back before reaching the collector. That is called stopping potential. So this is the one, in this case, that kinetic energy, the maximum, the kinetic energy of electron, kinetic energy of ejected electron is going to be EVS, right? ENVS. So this is the one, and this formula we already know this one, right? K equal to h nu minus h nu minus h nu 0. So value of K, instead of K we have written EVS. So at this point, kinetic energy of electron is equal to EVS. Okay, so this is the very important one. Okay, I will give you just brief idea, which is at least it will be clear to you. Okay, so this is a evacuated uh, glass tube. Okay, this is a metal surface. Okay, this is anode, and this is galvanometer, where photoelectric current is measured, and this is the potential, which is varying potential. Okay, and Okay, this is evacuated glass tube. Okay, this is metal surface. Okay, this is the light which is incidence on it. Okay, light will incident on it, and as light will incident on it, the electrons will get ejected, and this is a anode. Okay, and it will attract the electron, and it will go to this side. Okay, and the photoelectric current will produced. Okay, that is electric current will produce, that is called photoelectric current. Okay, and when we reverse, and this is a very potential. If we reverse the potential, okay, in that case the electrons will be prevented going there, right, and photoelectric current will decrease, and uh, and when we reverse the current and we keep on increasing at the level where the most energetic electrons will be turned back by the anode, right. So that thing is called, that potential G of the electron is going to be equal to EVS. Okay, EVS. Okay, that is mod EVS. That is the one, and by that and then we have put this value here. I have given brief idea. Okay, so this one and in Einstein equation, and we have replaced EVS by K, sorry, K by EVS, and we got this equation. So all these equations are very important equations. I hope you understand what is stopping potential as well. Okay, so now we are going to solve some questions related to photoelectric effect and black body radiation, which are asked in IIT-Jam exam. Okay, yeah, hi Priya, good evening Deeps. Okay, so now we are going to solve questions which are related to the photoelectric effect, which I have taught till now. Okay, okay. So we'll start with questions related to photoelectric effect first. So okay, so the first question, that is related to black body radiation. Okay, question is, this is the question. Which is asked in IIT-Jam 2007, and it is related to black body radiation, which I taught yesterday. IIT-Jam 2007. Okay, question is very simple question, formula based question. The spectrum of the black body spectrum of an object O1, an object O1 is such that is such that its radiant intensity its radiant its radiant intensity radiant intensity means intensity per unit wavelength interval. Okay, intensity intensity per unit wavelength per unit wavelength interval intensity per unit wavelength interval radiant energy radiant intensity is maximum at wavelength of 200 nanometer at wavelength of 200 nanometer. Another object O2 has the maximum radiant intensity maximum radiant intensity at 600 nanometer at 600 nanometer. The ratio of power emitted the ratio of power emitted per unit area emitted per unit area by O1 to that of O1 to that of O2 is okay. Options are number A 1 upon 81, number B 1 upon 9, number C 9, number D 81. Okay, so these are the options which are given. Okay, I'll read the question for you again. A, a black body spectrum. So a black body spectrum of object O1. So object O1, the black body spectrum of object O1 is such that its radiant intensity means intensity per unit wavelength interval. Okay, its radiant intensity is maximum at wavelength 200 nanometer. Okay, intensity is maximum at wavelength. Okay, intensity is maximum, radiant intensity is maximum at 200 nanometer, right? Another object O2 has the maximum radiant intensity at 600 nanometer, right? The ratio, okay, that 200 nanometer, or the second one is 600 nanometer. So this is 200 and this is 600 nanometer. Okay, this is the spectrum which is given. So we know, so we know the Wien's displacement law. Okay, which I explained in last lecture. Wien's displacement law. That this figure I made it just to make you understand. Okay, Wien's distribution law. Sorry, Wien's displacement law. Wien's, we know, right? What it says? It says T is displacement law. We're using this. So in this case it is going to be, now we can easily find out lambda 1 upon lambda 2. It is going, we can write lambda 1 upon lambda 2 equal to T2 upon T1, right? Power is proportional to T to the power 4. Power per unit area or intensity is proportional to T to the 3 to the power 4, and that is going to be 81. Okay, so this is the answer, guys. And the what is and the D. That's all. Okay. Yeah. So note down all the formulas and practice questions as much as you can related to those formulas, right? Related to Stephen's law, Wien's displacement law, uh, Planck's law, Rayleigh-Jean's law, and others, right? So the more you practice, it's very good question. Hmm. A light described by light described by light described by the equation E equal to 90 volt per meter into sine 6.28 into 10 to the power 15 minus 15 per second per second into t. So I'll write it again so that it will be next. described by the energy E equal to 90 volt per meter into sine 6.28 into 10 to the power 15 per second into t plus sine 12.56 into 10 to the power 15 minus 15